The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you for joining the webinar today. My name is Jamal Mazhar, founder and CEO of Kavo. With me is Joydeep Biswas. He's a senior developer of Kavo. And we will be covering how to deploy and manage applications in the cloud using a web service API that we have introduced for developers, so developers can easily deploy applications through the API instead of having to use the web interface. In terms of logistics for this webinar, please ask questions through the window that you have on the webinar. Everybody is muted, so we cannot hear you. Also, if you have any other issues during listening, please mention that in the question window. We also have another meeting which will show us, to tell people how to use iMod application itself on June 17th. So the scope of this meeting is not as much to cover how to use iMod application. The scope of this meeting is to basically go over the web services API. So with this said, I'm handing over to Joydeep. Joydeep, please go ahead.
Hi, I am Joydeep Biswas from Kavo. Today I will demonstrate to you Kavo Web Services. Kavo's iMod application offers single-click deployment of complex multi-tier applications in the cloud using Kavo's dynamic system template technology. It also offers runtime management of application infrastructure in the cloud. For example, it allows handling of demand variations by automatically adding or removing resources. Currently, it supports a number of clouds, including Amazon EC2, Rackspace, IBM, and Eucalyptus. iMod is a web portal and is accessible through a web browser. But if you want to programmatically interact with iMod by developing your own client programs, you can do that by using Kavo Web Services. Kavo's web services are accessed by the SOAP protocol, that is the Simple Object Access Protocol. It uses document literal wrapped style, and it is WSI compliant. So far, we have exposed some key functionalities of Kavo's iMod application through Kavo Web Services, but we will keep adding more to it in future. The documentation for the Kavo Web Services is available in our Kavo wiki, and it is available at this URL, and the page is open in front of me. Here we have provided a number of sample clients which you can refer to while developing your client, and we have provided these samples in multiple languages, including Java, C#, Ruby, and Perl. And functionalities so far, we have exposed ability to deploy and undeploy systems, ability to start and stop systems, ability to set or delete thresholds for triggering custom events, ability to execute custom events right away, etc. But as I mentioned before, we will keep adding more to it in future. Today I will show you how to develop clients in Java. For these clients, I will use JAX-WS with JDK 1.6 and Eclipse 3.4 IDE. So I have JDK 1.6 installed on my computer, and I will navigate to that directory where it is installed. And this is the bin directory where we have a number of tools. One tool that I will use today for the purpose of developing the web service client is WS Import. It's used for generating client stubs from the web service digital file. So I will generate the stubs in this directory, that is KWS, and I will show you how to do it later when I actually do it hands-on. In the first example, I will launch a simple system for bringing up the Jira application in Amazon EC2. And what does bringing up an application mean? It means launching provisioning servers in the cloud, which is EC2 for this example. That means we have to, in the first step, launch or provision a number of servers. Then, after the servers are provisioned, we have to install the necessary softwares, and after installing them, we have to configure them. And for the simple Jira application that we will be using first, these softwares are JDK and Jira binaries. And in addition, we may have to perform certain tasks like configuring firewalls, etc. So all these steps are involved in launching an application in cloud. Next, I will log into the iMod application using my account. As I mentioned, that Kavo's iMod application is a report that is accessible using a web browser. So first, I will give you an overview of how complex multi-tier applications are represented in iMod. And how it is done? It is by specifying all the structural and runtime information of the application using XML. So this is the entire page of the application open in front of me, and we provide a number of best practice templates. These templates are generic templates which you can create your systems from by specifying certain information. I will show you how to. For example, there is a system template for a PHP Colab application in Linux, and it is for the EC2 cloud. And you can see it is XML, and this XML specifies the structural information, like how many tiers are there in this application. In this case, it is 3, because it's a 3-tier application. And in each tier, you can have different types of servers, and that is also. At the bottom section, there are a number of actions. And these actions are, you can consider them to be functions. These functions are written by you, and you can inject these functions in different phases of workflows that run in the context of this application. One example is the system startup workflow. That means the workflow that is responsible for launching this application in the cloud. And as I already mentioned before, launching the application involves provisioning the servers in the cloud and installing and configuring softwares and doing other tasks like configuring firewalls. At the further bottom section of this XML, we can define a number of custom workflows. That means these workflows you can specify completely, and I will show you that these workflows can be executed in different ways. You can execute them right away, or you can execute them in response to some event generated by a monitoring system. Also, you can execute them by scheduler at a scheduled time. So this is a 3-tier application. This is a complex system, but as I mentioned, for this, for the first client, I will use a very simple Jira application, which is a single tier application. And let me open the system template for that. Now I will instantiate this template, and I have to give it a name. So I'm calling it test-Jira. But as I mentioned, this is a template, so it does not have all the necessary information in it for it to be a complete system. So you have to provide certain details to complete the specification of the system, and you can do that by using this form. So let me provide this in. Some of them are already provided, and some are missing. So I provided the missing information, and now I have a system definition for a single tier Jira system. So next, what I will do is I will develop a simple Java client for launching the system. So this is what I did is definition of the system. We have to define the system first. The next thing we can do on it is starting the system, or maybe adding some event on the system, etc. So I am using the Eclipse IDE for developing the simple client. So let me add the Java class for it. Let me call it R. I mentioned that we have provided a number of sample clients in our wiki, so instead of developing everything from scratch, I will use what is available on our wiki. So this is the sample for starting a system. I copied and pasted code from here. So this is so simple, only a couple of lines of code. So we are capturing the URL of the web service digital file in the URL object. Then we are mentioning the qualified name of the service. After that, we are creating a service object. This service object provides the client view of the web service, and it also acts as a factory for proxies for the service endpoint. In the next line, I retrieve the proxy that I just talked about using the get port method. So the EIF, I can also call it. The viewer is working.
Question for you. You have already created the web service stubs for these client from for this web service client stub for this.
Yeah, I have already created them, but I will demonstrate how to do it as well. Yeah, so as I mentioned before that we are using the WS import tool for generating the stubs. Show it how to, it's very simple. Just you have to use the WS import command and specify the variable. It is parsing the visitor and generating the code. Now, and this folder is linked to my project. So the classes it generated is accessible from my application that I'm developing. And this Kavo Web Services class is the class that is generated by the WS import tool. So now I have the proxy, and this is a proxy for the remote service. That means we can invoke methods on this proxy, and the communication with the remote service will take place automatically. So what I'm going to do now is invoke the start system method on this proxy. So I have to start the system that I defined earlier. The name of the system is test here, so I have to specify that name here. And one thing I would like to mention is that in every web service call, we have to pass our INOT credentials, that is the user ID and the password. And for the sake of privacy, I have kept those user ID and password for my account in a constants file so that it is not visible. So I will just refer to them from the constants file. So now I am done. So the client is ready. Now we have to test it. So it finished execution. Let me see what is happening on this side. And there you are, the test application is under the process of launching. And you can see the server is in the pending state. That means a request has been sent to the Amazon EC2 provider, and new instance is being provisioned there. And while this system comes up, I will describe certain details about this XML. So this is a very simple, trivial example, so it will be easy to understand it. So this is a single tier application. So there is only one tier in it, but the PHP Colab application was showing you before is a 3-tier application, and it has 3 tiers in it. Anyway, so in the XML, the element in tier represents the multi-tier application. In this case, it's a single tier application. And nested within the in-tier element is a tier element. Actually, there may be a number of tier elements if there are multiple tiers there, but in this case there is only one tier, so there is only one tier element here. So we have one in-tier element within which is nested a tier element, and we provide details like tier name, etc. And in a tier, you have to specify what types of server you want there, and you can do that by nesting this server types element inside the tier element. As this is an Amazon EC2 example, we have to specify our Amazon account for provisioning servers, and also have to specify details of the server that we are going to provision there, like the image from which the instance has to be provisioned, the instance type, the security group, and a lot of other things. And Amazon servers are specified by using AWS. So this is the AWS server element, and information is also specified there. and each of the entire tier and server type elements have their corresponding workflows. And you can specify workflow hooks using this post startup section. So you can see in the section there is one post startup section. Inside the tier element there is also one post startup section. And as I mentioned earlier, actions are similar to functions, and we can invoke these functions from this post startup section, as we have done here. So this install GRE action or function is being invoked from the post startup section of the server tier. What it means that after the server is provisioned in the cloud, this action will be invoked. After the instance is successfully provisioned, a script will be executed on that instance. And what the script does is it installs GRE on that instance. And also, from the post startup section of the tier, we are invoking the start Jira action. And what Jira do? It downloads the Jira from a location, and then extracts it, and then starts it. In the meantime, the server, the system has started, has successfully launched, and you can see the state of the system is running, and the state of the loan server in the system is also running. So I will check whether the Jira application has been really brought up. So I can do that by extracting the public DNS of the server and specifying the port at which the Jira application has been configured to start. So you can see the Jira application is online now. And all this was done by a single web service call. So it is that easy to programmatically interact with IMOD. So let me do something else. Let me stop this. And that would be simple as well. Just mention stop in place of start. And you can see the test Jira application is shutting down. So it is state is alternatively, you can say that the shutdown workflow is underway. So in the first example, I started pre-defined application. That means the application was already there in IMOD database. We just sent a request using web services interface to launch the system. But we can define the system in IMOD as well by using a similar web services call. And I will show you how to do that. So let me develop another Java client for that. I will not do it from scratch as well. I have one already developed. I will copy code from that example and step by step build the client. Maybe I do it using the code I developed in the first client. IMOD allows you to export an existing system definition from IMOD to your local drive so that you can share the system with others, or maybe you don't want to keep the system definition in IMOD database. You want to delete it from IMOD database and keep it on your local drive, and maybe later you come back with it and deploy it when you need it. And maybe you do some modification before deploying it. So we have export system functionality for exporting existing system into local drives. And this is the local drive, and here the system has been exported. So this is the path to the exported system definition file. So now using this code, what I did is I read the XML file from my local drive. Now I will make a simple web service call. To actually deploy the system. Let me call it by the name Jira New. And run it. So you can see the Jira New system is there in iMode database. That means by the web service call, it has indeed been deployed in iMode. It was not there before. So I can delete it from here by using deploy system button and rerun it. So you can see my system is not appearing in the system list. I run my client once again. It is done. Now I will refresh. And Jira New is there. That means it has been successfully deployed. Now within the client, I can make the services. Say I want to deploy the system and afterwards launch the system as well. So I can combine this with a start system call. And I have to delete it because otherwise it will complain that a system definition with the same name already exists.
So now you're deploying and also going to start the system. So there are two calls that you're doing. One is deploying a new system and then starting the new system.
Yeah, and you can see not only the system has been deployed, when you deploy the system for the first time, it is in the inactive state. But now it is in pending state. That means it has been started as well. iMode Web Services also supports scheduling certain events at certain times. And I demonstrate how to do that by using iMode Web Services API. As I mentioned before that, you can specify inside the system definition XML a number of custom workflows. And I told that these workflows can be, there are multiple ways of executing these workflows. You can execute these workflows right away. You can execute these workflows against some monitoring system trigger, or you can execute these events at scheduled times by scheduling events. And we have a similar method available on the endpoint interface for scheduling events. So the parameters, some parameters are common, like the system name, the event name. Event name is the name of the custom workflow. And let me choose the system scale-up event. And this workflow is responsible for scaling up the system. That means adding extra instances to the running system, as the name suggests. So in the event name parameter, I specified system scale-up. So this is the frequency I want to execute this event only once. So I specified once here. And context param string is something that is needed for passing extra to this event. We do not support this as of now. We will add the support for passing parameters to events in future. And this is the start date. That is when the event will be executed. So what this code does is it creates the start date object, which is 7 minutes from now. And I have to, so it is already passed there. So what this whole application does is, in the first step, using the first web service call, it deploys the system. Then it schedules an event. The name of the event is system scale-up, and an event is a custom workflow. And the system scale-up custom workflow is responsible for adding one extra server to a running system.
Jaideep, since the system is already running, so in the interest of time, can we just execute this event on the running system? You just
we
started.
can do that. Yeah, we can do that as well. So we have the system already running. So you're right. I mean, it's better not to do what I did before. So I will just comment out the extra code.
You just need to comment out the deploy and start system commands.
Yeah. So there is this fire event API available for firing an event right away. So now I will execute it.
So, I mean, can you just explain what this Fire Event API is going to do exactly, and after the server will start, what will happen exactly?
So what this Fire Event API does is it fires an event right away. That means there are, as I mentioned, there are multiple ways of firing an event, and this is one of them. So you want to fire the event right away. You don't want to schedule it for a future time. You don't want to execute against some trigger from the monitoring system, but you want to execute it right away. And that is what this Fire Event API does. And you can see after I executed the client for firing the event, the Fire Event workflow is underway. So what it has done is it has sent a request to the provider for provisioning an extra server. That means there was only one server before. Now there are going to be two servers in the system. And after provisioning the server, it will configure the new server in the same way it configured the first server. So essentially, it is scaling up the system. It is scaling the size of the system from 1 to 2. And let's take a look at the scale-up, system scale-up workflow. There are two sections here. One is the pre-process and another is the process. In the pre-process section, we specify which server to create new instances of and how many new instances to add. By using the role attribute, we are mentioning that we want to add new instances of the Jira tier default role servers. There is only one here because this is a trivial system, and count is equal to 1. And count is equal to 1 means only one server will be added. If I had specified count is equal to 2, then 2 extra servers will be added. And in this process section, what we are doing is we are installing the necessary softwares and configuring them in the same way that we did for the first server when we first launched the system. You can see there is invocation of the install JRE action, which installs JRE on the new instance that is going to come up, and this start Jira action is being invoked after that. That is responsible for downloading Jira and starting it. And then the flow has finished. So you can see now we have 2 servers in the system, and all of them are up and running, and the system state is also running. So we can easily see that the by the one single web service call to the Fire Event API, we have been able to scale up the system by count of 1. And the client program is very simple in this case as well. So we have still time left. So
yeah, so I think like what we'll do is right now, I think as you have, Joydeep has showed you how easy it is through API to deploy this complex system with software installation just through a simple web service call, scale up a system or schedule an event, or even like, there is other APIs that are available. So I think we have about 13 minutes left in this webinar. So at this point, please ask questions that you may have. There are some questions that are already on the line, so I will start going by them one by one and let Joydeep answer those questions. So Joydeep, the first question I have is, you showed a single tier system. It says that we can deploy multi-tier system. Is it possible to deploy a multi-tier system using the web service API, and is that something which is easy to do?
Yeah, we can do that.
I mean, can you very quickly, if possible, show at least the APIs or how we will do that?
Yeah. So it is going to be very similar to the first example we did for deploying a system. So I will go back to there. So let me give it the name PHP Colab, because that is the 3-tier application that I will deploy now. So I have the code for reading the XML, and I have the code for deploying the system from that XML. All I have to do is specify this XML and how to do that. I have actually I have a copy of the system I exported before in my local drive, and the system is PHP AWS.
There is a PHP AWS already deployed.
Yeah, but by a different name. So let me delete this. Actually, the name I specify here is going to be the name of the system. Even though the XML file from which I'm deploying the system is PHP AWS.xml, still this is the name by which the iMod will call this system. But anyways, I will deploy the existing one. Let me see what happened. So these people are deployed by web service call. So you can see it is in the next state. So using the web service call, we have been able to deploy a 3-tier HTTP application from an XML that was kept on my local drive.
So no, this is great. So I think the next question I have on the list is that you are saying that the web service API is currently something that we are working on and we are adding more functionality. Can you briefly go over what the current functionality that is available through the web service API?
I did before, but maybe I have been too brief, but I will do that once again. So this is the list of web services APIs. That means these are the functionalities that we have exposed to web services. And we will be adding more to it in future. So we can see we have deploy system that I already demonstrated before. There is also undeployed system. That means you can undeploy a system using the web service as well. Then we have ability to start and stop systems, and I have demonstrated both of them in this webinar. The third is ability to set or deliver thresholds for triggering custom events. Using this API, we can create an event. What does create an event mean? It means you specify to the monitoring system. Actually, I should have mentioned this before that whenever we launch an application using our iModeNTR engine, all the instances or servers that come up are added to the monitoring system list of servers, and the monitoring system monitors all the servers. It monitors for certain predefined metrics. And using that, you can define certain triggers in the monitoring system. So how do we do that? We specify which servers you want to define the trigger on. Maybe the system has 10 servers and you want to define trigger on 3 servers. You can define the trigger individually on them, or you can create a group of these servers and create an aggregate metric on them. You can specify different details like the threshold, for example. The metric is CPU utilization. And you have to specify a threshold for that. I mean, when will the monitoring event trigger the event? You have to specify a certain threshold. For example, we want the trigger to happen when the CPU utilization for the group of servers exceeds the 50%. So you have parameters for specifying that threshold and the relationship with the threshold. So there is this relation parameter, there is the threshold parameter. There are also parameters like priority and severity, and there is parameter by which you mention whether you want an email alert every time the trigger happens. And so this is the create event API that does that, but I could not demonstrate this one in this webinar because it is a little more complex than the examples I already demonstrated.
I just want to add here for the event trigger API, because what we are doing is we are setting a threshold for the monitoring systems to automatically trigger the event. So in this demo today, that our tutorial that Joydeep was covering, we fired an event through calling an external API, how to fire an event. Then we also covered how to schedule an event. In this case, you can actually define trigger. So if you want to run manage your application in autopilot mode, the system, whenever the threshold is breached, the corresponding event or complex workflow that you have defined will be automatically executed. So, and you can define any custom workflow. It doesn't have to be scale up or scale down. It can be something like if there is a security breach, you shut down certain port. It can be any event. So you want backup at a scheduled time or backup on demand. So those are the kind of things that you can define here, and it gives you tremendous flexibility. Sorry, Jaideep, go ahead and please continue with the.
Well, as I already mentioned, that there are 3 ways of executing custom workflows. One way is doing it right away. Another way is doing it by using a scheduler at scheduled times. And the third way is against some event triggered by the monitoring system. And this is the number 3, ability to set and delete thresholds for triggering custom events is what it does exactly. And you can see there is the event name parameter here as well. So if you specify system scale up and specify threshold say 50 and the relation say greater than, then whenever the CPU, and say you specify the metric utilization, whenever the CPU utilization metric process the specified threshold, the system scale up workflow will be executed. And if CPU utilization goes up, means that you need to add more resources to the system so that the system can handle increased load. And this is how to do it. And there is ability to execute events at scheduled times, which I almost demonstrated to you. And there is the ability to execute custom events right away. So this is the list of current list of functionalities that have been exposed using Kavo services.
Thank you, Jaideep. I think there are some more questions, and what we will do is we can follow up with the people offline. This tutorial today covers on how to use the iMod application through Web Service API. We also are going to do a tutorial on June 17, similar 1-hour tutorial on how to use the iMod application, the web application, and especially how to create system definition file. We have a UI wizard to help people create system definition files, so you don't have to create that XML from scratch. So thank you so much for taking the time for joining this webinar, and hope you use this and enjoy it, and please give us your feedback.